Okay, so hopefully that's given you an understanding of the relationship between the equation and the graph. Now, one thing we need to do with this is to model. I'll just get this back to the basic sine function, and if I just change these axes, you'll see that I've put in some values or some. I just plotted some random data. Okay, these points were just randomly plotted, but in a basic shape of a sine curve. So you'll get some questions where you're given data, or you might be given scatter plots like this, and you're asked to find a model for it. Now, the first thing to notice is that the basic shape appears to be a sine function. Okay, we're going up, we're coming down, coming up again, so it looks like it's periodic. So we can model this with using a sine function. So now we need to get the graphical features from this and start constructing the equation for this. So do a bit of work over here. So let's get the important features. So first of all, the principal axis. Principal axis appears to be around about here. So that's around about, say, 22. So that will tell me that C is 22. Let me just put the general equation in here so we know what we're referring to. Okay. So principal axis is around about 22. Of course, these numbers are very approximate. If it's on graph paper or it's on your calculator, you might be able to get some more accurate values. This will just give you the general idea. Right, now the amplitude is probably better actually if we just think about the maximum and minimum values. So this is around about, let's say, 33 for max, and the minimum value here is, let's say, about 12. Okay, so because that's I've got the maximum and minimum values here approximately, so the amplitude is going to be half of the distance between these. So if I do 33 minus 12 and halve it, that's 21 over 2, so 10.5. So my amplitude would be about 10.5. So that will go here, 10.5. That will be my A. Now I could just I could estimate the principal axis to be around about 22, but let's work it out from maximum and minimum values. I'll just make a bit of space for myself here. Okay, now the principal value is actually the mean of the maximum and the minimum. So so the principal axis is 12 plus 33 over 2. So that's 45 over 2. Well, it comes out to be 22.5. Okay, well, we estimated 22. This might be slightly more accurate. Let's use that value there. So C will be 22.5. The principal axis will be y equals 22.5. And finally, the period, which is perhaps the harder one. We need a reference point here. Well, this looks like a kind of where it's starting. So if I look to see where it repeats itself, I've got a bit of a problem here because it doesn't repeat itself on the graph. I can see it's going to be off here somewhere where it starts to repeat itself. So what I can do is I can think about maybe a half period and go from here, say, down to here. Okay, that finishes the top part, and then the bottom part will be the same length. So from here to here is round about, I don't know, what's that, 200, maybe a little bit more than 200. Let's go with 200 degrees. That's half the period, of course. So so I'll say the period is about 400. Okay, this is very approximate. So that means B is 360 divided by the period. That's 360 over 400. If I simplify this, that's 36 over 40. 4 goes into both of these, so that's 9 over 10. So I could use fraction, or if I prefer, there's a nice decimal that has the same value. So there's my B. Okay, so B could be 0.9. So I could my model could be y equals 10.5 sine of 0.9x plus 22.5. Well, let's put that in to this this function and see if it matches. So y equals 10.5 sine 10.5 sine 0.9x 0.9x. I could put it in like that, or this one works out nice as decimal. If I had a fraction which didn't, then I could put it in like this. Okay, and the c was 22.5. The principal axis was y equals 22.5. That's 22.5. Okay, let's see if it matches. Okay, well that's not bad. Okay, so this is a model. Doesn't match exactly, but very few models actually do. So you might want to try to adjust these values slightly, try to get a better fit, but it's a good place to start. And it's also important to understand that in any case, models generally aren't completely accurate. They're approximations. We're taking lots of data and we're trying to approximate them with an algebraic model, because the algebraic model we can manipulate, we can substitute in values, we can use it quickly. It's more convenient for us. Doesn't necessarily mean it's the most accurate. And that's it.